Hello, welcome to another very exciting creature tutorial. This tutorial is going to cover the brand new flow system. Now, this is the second part in the flow system, particle system series tutorial. I recommend you watch the first introductory video to understand the basic concepts of using flow, because in this tutorial, we're going to learn how to make this super cool flame fire animation that is coming off this branch. All right, so we're going to learn actually how to make pretty cool, realistic looking fire with embers and smoke and all that using the power of Creature's flow particle effects procedural system. So without further ado, let's get started. Right, so let's start with a clean shot. Now this shot has the branch already set up. It's just a bunch of basic wind and bend physics motors. Again, if you're not familiar with the motor system of Creature, I recommend you watch some previous tutorials on how to use the motors of Creature, but we're focusing on flow here. So the first thing we're going to do is click on Animate and start off the flow system. So click on Flow Advanced Particle System. Okay, so in this example, the first thing we're going to do is we're going to make a new solver. Now, in order to simulate realistic fire, you need some kind of fluid dynamic solver, and Creature actually has this solver available. There's two kinds of solvers currently right now available in Flow. There's the regular solver for normal particle systems, and there's something called the grid solver, which we're going to be using for the base fire fluid flow. So click on grid solver. So this will actually simulate the equations of motion of fluid dynamics. So it's pretty complicated and pretty cool, and we're going to use that to simulate fire. So create the grid solver, and then the next thing we're going to do, as usual, is to make a source, right? So let's make a radial source, all right? And as usual, in the previous tutorial, we want to actually make the source emanate from a particular position on the branch, right? So we come back here, we go to sources, and we click character embed position. Again, I recommend you watch the previous tutorial to get familiar with how these basic concepts work in the flow procedural system. Now, we're going to set the region or the mesh of the source. So click on it, and we go to the regions tab, we select the branch, and then we click set. Okay, so we have the branch here. Now we're going to actually set the position where it's going to emanate from. So move your mouse over to embed try, click on it, and then let's move this red dot maybe somewhere over here, maybe. Let's try this spot. Let's make it come out from this spot. How about that? And click on set. Okay? And then finally, just like in the previous tutorial, we connect up the output positions, right? So output Y, output X, and all that goes into the position slots of the source. Okay, and we're not done yet. Let's adjust the spawn num. 10 is a bit too much. Let's try 2 for starters. And because we're doing fire, this is what's really interesting about fire. We want to make it really cool, really interesting. So we're going to use sprites, but we're not going to use a single sprite image. We're actually going to click use sprite animation, and now we're going to select our items that we're going to use for sprite animation. Now I already have a bunch of particle sprite frames set up, so I'm going to select these guys. So this is a sequence of a fireball getting blown up. We'll use that. You'll see in a moment why we're using it, so click OK. Right, so now we have 9 items in our sprite animation. We could maybe change the frame pause to 2, right? Okay, so we're done with that, and now what's left is we have to connect it up to the particle grid solver. So connect the source up to the source, like so. And of course, with this, we still need some kind of field to actually drive the fire, right? So right-click, create a field like gravity, and we're going to invert the gravity. But before we do that, we connect up the field to the field. Yeah? And we want to invert the gravity because we want the smoke to go up, or the fire to go up. So instead of something negative, let's give it a positive value, maybe like 20. Now, one thing I want to mention before we continue about the grid solver is that we have a couple settings you should pay attention to. These are the settings you should care about: the grid res X, grid res Y, and grid size X. Now, the first two are the resolution of the fluid simulation. The more detailed you want it to be, the higher the values are. Now, 100 by 100 is quite detailed because we're going for a high quality simulation, but if you don't want to pay the cost of it, I recommend 50 by 50. It should still be quite good and give you much faster response times, iteration times, I mean. And then the other thing you probably want to size up is the grid size X. Now, this should be at least 3 times the size of your character, because the fluid sim is going to be a grid that's overlaid on top of your character. It's a grid, like a rectangular grid. So if it's too small, you're going to see the particles confined to a rectangular space and hit some invisible rectangular barrier. So here I've set it to 150, which is about 3 times the size of my brush. You can actually see the size, or check the size of your character in the rigging mode, and then set the size appropriately just to make sure there's enough grid space to simulate your particles. Very important, all right? So these are the 3 settings I have for the branch. But again, if you have particles hitting some invisible barrier, increase the grid size to make sure that it will go through. Now, one thing I'm going to do now is to change the radius of the source, because I feel like the particles were too spread out when they were initially spawned out. So I'm going to change it to this value again of 3 and try again. So this will make the particles clump a bit closer. There you go. That's actually the result I want. And I will again increase the number of frames, and let's see what we get. So now we can actually get a rising, sort of a rising flame with particles much closer together when they're initially spawned as they go up, right? That's what we're going to do, and let's see if that gets the effect we want. Okay, that's more like it, right? So we're getting a bit closer to what a flame might look like. Let's do a few more tweaks, shall we? So we should give some variation to the size of the particles that are getting spawned. Agree? So maybe we should change it from, say, 0.5 to 1. So this means that there's going to be a variation of size of 0.5 to 1, randomly distributed as the particles get spawned. That makes the simulation a bit more interesting. And of course, we're going to make even more tweaks along the way to get to the result we want. But you can see it's very fast to get the results you want with the system. It's very, very convenient as well. That's the power flow. Okay, so now there's a bit more variation. There's small particles, large particles, right? Now, one thing about particle system is that the colors, the initial emission color is not completely opaque, right? If your particles are actually opaque, it doesn't look like fire. So maybe I'll try a value of 0.7 for these particles to make it more translucent or transparent. And let's see what we get, because we're going for a fire effect here, not a solid effect. And this will help as well to sell the look of the fire. So let's see what happens now as it's simulating. Okay, so that's a bit more reasonable. We can probably tweak it a bit more. Let's try 0.5 maybe. Take the opacity down even more to sell the look of the fire. Let's see what we get. And hopefully this will give us a more transparent fire, which is what we want. So off it goes to the races to simulate, and we should get our results back. There, that's a bit more like it, right? We can probably increase the number of particles as well, yeah? Or maybe the fire is going up a bit too quickly, so I'm going to decrease now maybe the gravity or the force upwards to make it rise a bit more slowly, so we get a bit more detail. But you can see what we're doing here. We come in here, we tweak parameters, and then we get the look we want. You iterate very, very quickly, and eventually you get the fire that we want. Okay, so here we go. Let's run it. Okay, so that looks a bit more interesting now. Great, so we're not done yet. The next step is we're actually going to make the fire change color as it rises up to become smoke, like a dark smoke. Okay, so how do we make it feel like smoke? So the way we do it is we want to change the color of the fire as it rises up, right? So what we want to do is we want to change the color of the fire particles over the course of its lifetime. Initially it starts out in its original color, and then we want to darken it. And the way to do that is to add what we call a sensor. So go into fields, or let me see, data. Sorry, data, and that's something called solver sensor. So this sensor thing is a very powerful node. If you connect it up to sensors, what it does is it will actually extract out all the positional, velocity, angle, temperature, lifetime, you name it, data from the particle system as it runs. This is for each particle. And so these are the attributes of each particle that are running at that particular time step in the solver. So you can actually, it's basically extracting data, hence it's like a sensor. It's like a thermometer. And so you can use this data to change the look and feel of the resulting particles of the system. It's super powerful. And I'll demonstrate to you what it does right now. So what we do is we create the sensor, we connect it up to sensors. And I am actually going to go to operations right now and create a Bezier map. So this is a curve that I can change based on what I want. Let's do the color first. I'm going to demonstrate to you the power of the sensor with something like a Bezier map. So what we're going to do is we want the particles to darken over the course of their lifetime. So we drag the lifetime slot into the X-val. So this feeds in the lifetime to the X-val, right? And then what we're going to say is if we look at our settings here in radial source, the lifetime starts at 2. So we're going to say the X start is 2, and then the lifetime obviously ends at 0 because it fades to 0, right? And what we're going to say now is that initially the color is set to 1, a factor of 1, and then when it's done, it's going to fade to say, maybe say 0.1. So we're going to take the value down. And then we can now change the curve. We can drag this Bezier curve to be however you want, right? So I'm going to do something like this. So it's going to slowly, gradually interpolate over the course of its lifetime to go from a color value of 1 to a color value of 0.1. Essentially, it's going to darken it. Once you are done with that, here is the magic. Let's drag the particle solver down. And all I need to do now is to connect up the Y-val, the resulting value scale, to the R, G, and B values of my particles, right? So this basically means we are going to not fade out, but actually darken the particles, right? So the scale is a multiplication factor on the color of the particles. So initially it's 111, which is full color, but it's going to use this curve to actually interpolate and change the brightness of the particles from 1 to 0.1 based on the lifetime of that particle. Pretty cool, right? So let's see, let's run it and let's see what we get. Let's see if it works. And we'll find out. This is very exciting. Now, as usual, as this running, I recommend you have a multi-core system because simulation takes advantage of multi-core machines to make it faster. Okay, so let's see what we get now. Look at that. Now you actually get some smoke rising out. That's pretty cool, isn't it? So as the particles come out, initially they start at this color, and then you see how they gradually become like a black smoke. So now we're actually getting somewhere. Isn't that pretty cool? It's pretty interesting. I think I'm going to take this down even lower, maybe 0.01, so we get some really, really dark smoke. Right? That's sort of the effect we want. So let's see what we get. This is super exciting. Now you can change the lifetime fade, of course. That's a parameter on the radial source to control how quickly the fire particles go from fire to smoke. Okay, let's run this again. That's pretty cool, isn't it? Look at that. Okay, so that's the first step, right? That's interesting, but it's not, you know, completely convincing yet. What we want to do is we want the fire to come out, but just like in smoke, the fire actually dissipates, so it actually enlarges in size. So we want the particles to actually grow larger over the course of the lifetime. And again, that's super simple to do in Flow as well. It's super powerful, as you see. All we need to do, again, is make another Bezier map. I go to Operations, Bezier map, okay. And now I am going to connect up the lifetime, again, to the X-val, right? And I'm going to say the starting value is 1. And then maybe I'm going to enlarge the particles by 2x. This is just a just a test, right? So I'm going to say the particles are going to grow by 2 times over the course of its lifetime. Oh, sorry, actually the lifetime starts at 2 and ends at 0, same thing. Sorry about that. It's actually the y start. The y start will start at 1 and end at 2. So this means that the particle is going to start in its initial scale size of 1 and then grow to twice the size. But the x start and x end are still the same. The lifetime still begins at 2 and ends at 0. Okay, so and then finally, let's drag this solver thing down. Let's connect him up. We're going to connect this y val to the size scale slots of the particles. So basically we're going to scale the particle up as the particle goes through its lifetime. Let's see what we get now. This will be quite interesting. So off it goes to compute, and we are anxiously awaiting the results of the simulation. It's very exciting. Right, so let's see what we get. Oh, look at that. So you actually see how the particles actually grow larger over the course of the time. I think it's actually pretty cool. Yeah, that's pretty cool actually. Now we can probably tweak, you can tweak the curves however you want. You can make them grow larger much faster. Like this is the Bezier curve I like to use typically. Let's run it again and see what we get. So you can see how over a course of iterations we already have something that looks somewhat like fire, and I believe if you tweak it a bit more, you'll get even more convincing results. So feel free to play around with it to get to the final result we want. Okay, so let's play it again. There you go. So now we actually have a fire type effect with smoke coming out. Of course, it's all at this point it's all tweaking. Yeah, it just depends on how much you're tweaking the particles to get the effect you want. Okay, so we're almost done with this, but this is just the flame itself. We're also going to add some embers to this smoke to make it even more convincing, and that's the next part of this tutorial. Right, so to add some embers, the embers are really fast things that fly off the part of the smoke. We're going to add actually a new solver. You'll see in a moment what we're going to do. So let's make a new solver. You'll see why we're going to do it. This time we're going to use a much faster solver, the regular solver. Okay, and just like in the previous case, we make a new source, a radio source. Yeah, and you should be used to this by now. We connect up the radio source to the source, right? So let's do it here. Okay, and we use the same region position, so same spawn position basically. So we set it from here, set it from here. You know, hook up the or connect up the position slots. Let's set a couple of values that we care about, maybe the radius to 3, right? And of course the region has to be set, so select the branch, set the region, we have the branch, great, okay. And we also want the sprite images. Now for the embers, I don't think it really matters what sprite image you use because it's going to be a tiny thing, so maybe we can just use one image and take it from there. Now other than that, let's change possibly the initial size because we don't want the ember to be too large, right? It's a tiny thing, so maybe we can try 0.1, and spawn num might be too high, so let's do 3. Okay, now what we're going to do now is we're going to use a different type of field. This is the magic. We're going to use fast fluids. Now the fast fluids field is a very powerful field. You'll see in a moment why. Let's connect it up first. It allows you to quickly simulate some kind of twirly fluids type behavior without paying the cost of the grid solver. So this is an alternative. Now it's not as realistic as the grid solver, but it does get you sometimes close to 70 to 80% of the way there. And this is the field that we're actually going to use to simulate the embers. We're going to tweak a couple parameters first. You can read through the documentation online to understand what these parameters actually do. But for now, I'm going to tell you I'm going to up the direction factor to 1 to force it in a direction that I care about, which is upwards. Yeah, because that's actually what where we want the smoke to actually go. Okay, and let's try running it right now, and let's see what we get. So it's going to run two passes. The first pass is actually the grid solver pass. That's the base fire simulation. And the second pass is going to run the regular particle solver with the embers. Obviously, the results will not be what you expect initially, but we're going to tweak it there. But I want you to understand the process. So that's the grid solver almost done. And here's the particle solver, the ember simulation, which is much faster because it's a cheaper simulation. And let's see what we get. Oh, we might have to tweak the lifetime as well. I think the embers fade a bit too slowly, but no matter, we'll tweak it right now. Let's run this in. And you can see, oh, that's pretty cool. Look at that. So now let's look at the twirly effect of the embers. That's pretty cool, isn't it? But of course, I think there's too many embers and they're not fading out quite nearly fast enough. So let's stop it. Let's up the lifetime fade again to 1.5. Yeah. And this time round, let us increase the starting and ending velocity because we want the embers to go really, really fast. So maybe you can start them at maybe say 10 and then the ending velocity of 30. So give it some variation. We still need to tweak the angle of how the embers actually emanate from. That's next, but let's see what we get from here first. So off it goes to the races. It's running the grid solver, and then it's going to run the regular particle solver. And you can see very quickly how we get a compelling fire simulation in no time at all. So there goes the second particle solver very soon. There it goes. And it's much faster because we're fading out the particles faster as well. Okay, so let's run this in. And okay, that's cool, but the embers are actually going off in the wrong direction. They're going to the right. So let's tweak the ember direction. So let's change the embers emission direction. So maybe let's try an angle from 80 to say 120. And let's see what we get. Let's run it. So off goes the grid simulation again. And after the first pass of it, it will run the much faster regular particle solver simulation. All right, well, look at that. So now we actually have some kind of ember type looking simulation that is going up with the base flame, right? And you can tweak it even more. You can make it actually more twirly by decreasing, by say maybe increasing the curl factor, maybe to say 2, and maybe decreasing direction factor to say 0.8. And we can also up the frequency maybe to 10, and let's see what we get. So tweaking these parameters affects how the fast fluids feel functions. I recommend you reading the documentation online, but in general what we're doing is if we increase the frequency, it becomes more erratic and more active, more noisy. That's basically what it does. And will give you more of like an amber sparkly effect, which is what we're going for. Okay, so there goes the second pass of the simulation, and let's see what we get. That's pretty cool. I think it's a bit too noisy. I think we increased the frequency of the fast fluids a bit too much. So let's decrease it maybe to 3. That could work. It's just tweaking values at this point. You should experiment with different values to get to the result you want. But in general, you can see we're actually almost there. And then I'm going to load up the final result from the demo that was posted online a couple weeks ago. And you can see the final result in its full glory in the creature window. Okay, so this is a bit more convincing actually. I think it's pretty cool. So you see that nice twirly effect you get from the ember simulation. And you know, again, you can keep tweaking this to your heart's content. I think the embers could also use a bit of alpha. So we could probably take the ember alpha down a bit. It's a bit too opaque for my taste. It's all personal, your personal taste at this point. You can also add a new Bezier map, a new solver sensor to make the embers, again, shrink over time to make it even more realistic. Right now the sky is the limit. You can see how just using this procedural node system, you can do a lot of things. It's extremely powerful. So I encourage you to play around with it to get to the result you want. You connect these nodes, you create the solvers. It's like a Lego set, essentially. And then you put them together to create a particle simulation. Okay, so let's see what we get now. And look at that. So now we actually have some kind of fire effect with embers emanating from the piece of wood itself. It's pretty cool. And this is just a short amount of tweaking. Of course, with more tweaking, you get much better results, which I'm going to load. I'm going to load the result that was shown in the grid demo. And this was done with a bit more tweaking. Obviously, results are better because we tweaked a bit more, but it's just essentially the same idea. You have two solvers, a regular grid solver, and the regular particle solver, right? And so there you go. So this actually has the fire and also the embers coming out. And this was a lot more tweaking. We increased the size of the fire, we increased the spawn num, but it was essentially the same game we played. We can take a look at the network here, right? And you can see again there are two radial sources, right? So there's a regular grid solver that we had here, and we also had a particle solver that was for the embers. And you can see for the embers I made something even fancier. I added a solver sensor. I changed the size of the embers as they go up as well. And also for the, let's see, for the regular grid solver, these are the settings as well. I actually increased the size of the fire, just to make it a bit more compelling. But it was the same idea. One grid solver and one particle solver with, solver sensors in the middle to tweak the size and the color of the particles over time. And so this is the end result. I think it's actually really cool that we can achieve this result with the flow system. It's I think quite impressive, and I'll encourage you to play around more with the flow system yourself to get the cool effects. This is the second part of the series. Stay tuned. We're going to cover even more advanced features of the flow system in Creature, and we're going to show you even more astounding effects that you can create with this procedural particle system. So stay tuned. Thanks for watching, and happy animating.